Every time you type a message to ChatGPT or Claude, the model never actually reads your words, it reads numbers. And to get from your sentence to those numbers, there is one critical step in between: tokenization. Today, we are going to understand exactly what a token is, why it exists, and how it shapes every LLM you have ever used. This is part two of the LLM Foundation series, and it is one of those concepts that quietly changes how you think about every AI conversation you have ever had. A token is the smallest unit of text an LLM processes, not a word, not a letter, something in between. A token is typically a common word, a word fragment called a subword, a punctuation mark, or white space. The rule of thumb is simple. One token is roughly four characters in English, or about three quarters of a word. The model never actually sees the word apple. It sees a number, for example, token ID 15234. Think of tokens like Lego bricks. You can build any word or sentence by snapping together a finite set of predefined pieces. The model knows all the bricks. It never encounters a brick it has never seen before. That is the power of tokenization. Let us look at real tokenization examples so this becomes concrete. The phrase "I love machine learning" splits into exactly four tokens. Each word lands neatly in one piece. That is the easy case. Now try "unbelievably tokenized." This splits into five subword pieces: unbelievably, then space token, then iced. The tokenizer breaks apart a rare compound word into smaller chunks it recognizes. Finally, GPT-4 costs 0.002 DAOs exclamation mark produces 9 tokens. Punctuation, numbers, and symbols each get their own piece. Notice how rare words split into smaller pieces, and punctuation always gets its own token. Every character is accounted for, nothing is lost, but token count climbs fast with technical content. You might wonder, why not just use whole words? Great question, let us find out. Problem 1 is vocabulary explosion. English alone has over 170,000 words in current use. Add names, slang, technical jargon, misspellings, and code, and the vocabulary becomes completely unmanageable. Problem 2 is unknown words. A word based model breaks completely when it sees ChatGPT or selfie or any word not in its training vocabulary. A subword model handles anything because it splits unknown words into known pieces. Problem 3 is multilingual support. The same model must handle Spanish, Hindi, Arabic, Japanese, and code all at once. The solution is subword tokenization. Algorithms like BPE and sentence piece find an optimal set of roughly 50,000 to 100,000 subword pieces that can reconstruct any text in any language. Let us put the two approaches side by side. On the left, word level tokenization. Each unique word becomes one token in the vocabulary. That vocabulary can exceed 500,000 entries. The words running and ran are completely different tokens with no shared meaning. Unknown words crash the model with an out of vocabulary error, and it only works well for the language it was trained on. This approach was used in early NLP models like Word2Vec back in 2013. On the right, subword tokenization using BPE or sentence piece. Words split into frequent subword pieces, keeping vocabulary at a manageable 50,000 to 100,000 tokens. Running becomes run plus ning, and now it shares the run piece with runner. Any word, any language, any typo can be encoded. GPT-4, Claude, and Gemini all use subword tokenization today. Here is the full journey your text takes before the model ever processes it. It starts with your text, the raw message you type. That gets handed to the tokenizer, a dedicated component that splits your text into pieces. The tokenizer outputs token IDs, a plain list of integers, one per token. Those integers are then converted into embeddings, which are just lists of numbers that represent each token as a point in mathematical space. Those embeddings flow into the LLM, a transformer neural network that processes the entire sequence. And the final output is a prediction for the next token, the most likely piece of text to come next. The tokenizer sits between you and the model. Your text never enters the LLM directly, it always travels through this pipeline first. Let us look at some key numbers that put tokens in perspective. GPT-4 uses a vocabulary of 100,000 tokens. That is every subword piece the model has ever learned to recognize. The rule of thumb is roughly 4 characters per token in English. So a 400 character paragraph is about 100 tokens. Here is something that surprises most people. Non English languages use about 1.5 times more tokens for the same meaning because the vocabulary was built with more English text, making non English subwords rarer and more fragmented. And the context window tokens in Claude 3 sits at 128,000. That sounds enormous until you realize it is roughly 100 pages of text. Every API call you make to GPT-4 is built by the token, not the word, not the character. Understanding token count directly impacts your cost. Now let us make this tangible with real examples. The casual greeting, "Hi there," costs just 3 tokens, tiny. "I love machine learning" is 4 tokens. The quick brown fox jumps over the lazy dog comes out to 10 tokens. Photosynthesis is a complex biochemical process lands at 8 tokens. Two of those long words each split into multiple pieces. Now watch this. GPT-4 costs $0.07 per 1K tokens for input, hits 14 tokens because of all the punctuation and numbers. And the Chinese sentence, "Ji qi xue xi hen yu chu," machine learning is fun in Chinese, that costs 13 tokens for just 7 characters of Chinese text. The same meaning but higher token cost. That is the multilingual tax in action. A short casual message uses only 3 to 4 tokens, but technical or multilingual sentences can use far more. You do not have to take my word for any of this. You can see it live. Head to platform.openai.com, Tokenizer, and try it yourself. Simple sentence. Type "I love machine learning" and 4 tokens appear, one per word. Every word fits neatly into a single piece. Now try a rare word. Type "unbelievably tokenized" and watch 5 subword pieces pop up. Unbelievably tokenized. The tokenizer breaks what it does not recognize into the closest known fragments. Finally, a technical string. Type GPT-4 costs 0.2 or 2 does exclamation mark and 9 tokens appear. Punctuation, numbers, and symbols each get their own piece. Now you can open this playground yourself and test any sentence. You will immediately see how the model breaks it apart. This tool is one of the best ways to build intuition for token costs before you write a single line of code. Let us bring it all together. A token is a subword chunk, the smallest unit an LLM processes, not a full word. Subword tokenization solves vocabulary explosion, unknown words, and multilingual support all at once. The rule of thumb is one English token is roughly 4 characters, which is about 3 quarters of a word. The context window is measured in tokens. It limits how much the model can remember at once. And non English text costs more tokens, while punctuation and numbers each count as separate tokens. Tokens are invisible to you as a user, but they are the foundation of everything: cost, context, capability. Next up in the series, how does the LLM actually predict the next token? That is where attention and transformers come in.